Hello everyone, welcome. I'm glad that you are still here with lunch smell appearing around. Have you ever asked someone, dude, where is my car? I don't know, when you parked somewhere and you don't remember where you left your car, or maybe when you uploaded a file into web3.storage and you want to know where it is. Well, I hope at least next time you use web3.storage you will ask. So today we are talking about verifiably dealing 1 bajillion tiny uploads. And so what is the purpose of this? Why we would even want verifiability for user uploads into Filecoin? So we have several ways to get files uploaded with SPs today. And getting arbitrary content into a deal may take quite a long time and expertise. And so our purpose is providing a simple and also verifiable pipeline to do this. So when uploaders upload content into Web3.storage, we want that they can query cryptographic proofs of the state of their uploads over time until they get into a Filecoin deal. So for this, we want to acknowledge requests and have signed proof of that, perform computations, and also transitioned states. It's also worth mentioning that verifiable cryptographic proofs is at the core of Web3. So it is also important for us, not only that, but also to decentralize the pipeline in a way that others can also be part of the pipeline and run their own service and workflows if they want to. I will start by getting some quick context into the room and get into the fun parts later. I'm glad that already some concepts were covered, so I don't need to go so deep into them. So this came into the context of Web3.storage. I guess everyone in the room already knows about it. So in short, the goal of Web3.storage is to provide the easiest way to get user data on the decentralized web. For this, we rely on IPFS content addressable nature. And so we have for free data verifiability, but also data anywhere. If you have a file stored in a Filecoin SP with Saturn, with the IPFS cluster, everything can be trustable retrieved. Also, over the last year, we have been adopting UCANs across the entire platform. And so what are UCANs? UCANs are a way of doing authorization, and as the name suggests, user-controlled authorization networks. Everything is in the user control. So they essentially allow delegating access without needing to share keys over the wire. So you can think of UCANs as an extension of JWT. In a way, they can even be used as regular access tokens like JWT, but they really shine when they are used in conjunction with the public infrastructure. You can consider a UCAN as simple as something that has encoded everything that you need to prove to the service that you are able to execute such a thing that you are asking for. There is no all-powerful authorization server. You don't even need to have a server. So with all of this, we can think of a UCAN as having all the information that one needs in order to perform the task, as well as the provable authority to do so. This brings us the question, can a UCAN be used directly as an RPC language? And the answer is yes, they can. So the idea is that a consumer receives a capability delegation from a service, and then it can execute it in its own schedule. There is a whole spec for this, UCAN invocation spec, link is in the slides if you are curious. So there is this delegation of a capability from a service to a consumer. This consumer can execute or invoke this capability, and then the service will execute it. When the service executes it, it will issue a receipt, cryptographically signed, with the description of what was invoked, and together what was the output of this invocation. But let's get a bit into practice to make things easier. So considering a service math.com that delegates a capability to Alice to request to execute a wide variety of math operations. And let's consider that we have on the left side a UCAN and on the right side a receipt. So the proof that the service executed this. Starting on the left side, we see that the first field issuer, Alice, wants to math.com to execute something for them. So the attenuation property is what actually it wants to execute. So it's a math sum of two numbers, and the NB field as what actually are the parameters of this RPC call. So Alice wants math.com to execute a math sum of A and B, and the proof field includes all the provable authority that at some point Alex got permission to do this by the math.com service, and of course it's still not expired. And of course it is signed by Alice per private key. So on the right side we have, okay, service executed, what Alice asked for, and then it will say, okay, so I issued this receipt, what I ran, the CID of the invocation, what was the output of it, and also this FX field that I will cover later, but the goal is for some time, in some situations you actually can't execute what is requested right away, so you can just acknowledge, okay, I received this, I signed that I will do this at some point, and please keep looking for this FX that I will show you later. And then, of course, it's also signed to show that the service actually executed this. So without further ado, I present you the new Filecoin pipeline for Web3.storage. We name it W3 Filecoin. You also probably have heard already of this new API that we are working on called W3Up. W3Up is a completely different API compared to our current API that is in production. So the current API in production already stores all our data in Filecoin, and now this new pipeline, we want it to also, of course, store stuff with Filecoin SPs. So in order for us to fully migrate Web3.storage users to W3Up API, it's a requirement for us that also we can store files in Filecoin deals for this. So we are using this opportunity to define a best practice pipeline to get files into Filecoin deals, where, as I already covered, each asynchronous step of getting from a file into a car file, into an aggregate, into a deal, and so on, everything verified, and users can query and see that each service did what it was asked for or is in the process of doing so. We also have open specifications that anyone is welcome to implement parts of the system and interop with us. Link is on the slides and so visible, but web3.storage/specs, and then you have the W3 Filecoin MD file. So W3 Filecoin is powered by 4 different services. Each role can be fully implemented, as I told you, and it can integrate with the system, considering that, of course, it has the UCAN authorization thing in order to interop with the other systems. So we'll presenting the cast as we go, so that you go from the smaller picture until the big one. And we will start by Storefront. So who is Storefront? Storefront is a principal representing a storage facilitator. So on-ramp product like Web3.storage. It ingests user or application data and replicates it across various storage systems, including, of course, Filecoin SPs. So let's start the journey of what W3Up does today. So we have a user will run a client, and with this client, a user wants to store some content with us. So what the client will start to do is convert the content into a car file, or maybe multiple car files depending on the size of the content, and it might be needed to be sharded so that it's more performant and also goes through our limits of what we are able to store into operation. So when a client asks Storefront to store, so a store add invocation from a UCAN, the Storefront will see, okay, does this client have permissions to store? And if so, the Storefront will just send back a pre-signed URL that the client can use in order to store each individual car file. So by the previous slide, Alice already asked to store a car file with Web3.storage, hopefully did it already, and now Alice wants to have this car file also going into a deal. So for this, Alice can compute the PCID on the client side and just issue UCAN saying to the Storefront, okay, now I have this piece and I want to store it with you. So as you can see, UCAN on the left side, issuer Alice, audience the Storefront Web3.storage, and what it's meant here is Filecoin offer. It's what Alice wants. And the parameters are what is the content that I want to store and what was the piece that I derived from it, of course signed and with the proofs. So considering that no error happens with this invocation, and actually Alice previously stored the file with Web3.storage, Storefront can issue the first receipt saying, okay, I got this, I will work on this. So Storefront might want to do some asynchronous processing, like, for example, for us, might be important if we don't trust really Alice so well to compute also the PCID on our end and see if it matches, because we don't want to go until a deal with a PCID that was generated by the client that might basically make all the aggregate not work. But if it's a trusted party, maybe we can skip the validation process. So we need to have this async moment, which means our receipt has the difference that I previously told you of this fx field, which has two things. So first, a fork task as a Filecoin submit. And this is basically a link for a concurrent task that follow up in this pipeline. As I said, this would be the validation step where we queue the piece to be validated. And then we also have a join task, Filecoin accept, which you can consider as a shortcut to the final task when actually this piece already made it to a deal, but we'll go there a bit later. It's also interesting to just cover that this, even here we rely a lot on content addressed primitives. So given that we already know right away how what the invocation of Filecoin accept and Filecoin submit invocations will be, we can immediately in the receipt say, this will be the CID where at some point we'll issue the new receipt. And that's the way that then they can poll right away by the invocation until we at some point have the receipt for it. So at some point, Storefront will validate and everything is good. So Storefront wants to submit this to the next stage of our pipeline, which is putting the piece into an aggregate. So it basically gets into a new receipt for the Filecoin submit saying, okay, a validation is good. I will put now this into a piece offer. That's the new fx join receipt there saying that the client now can see, okay, this is done. The Storefront already signed this receipt, and now I can continue in looking for the piece offer while keeping track of what is happening. So I already spoiled you a bit, but the next piece in the puzzle is the aggregator. And the aggregator is a principal representing a storage aggregator. So Web3.storage, as you know, onboards any type of content. This content can be quite small. And as it's naturally then, we also will need to rely on a data aggregation in order to obtain bigger Filecoin pieces that actually we can get into a deal. We also ingest quite a lot of content, so we need to have an aggregator that not only gives all these cryptographic proofs of what it's doing, but also that it scales and can handle a lot of traffic, and also that it can create aggregates in different ways according, for example, what is the Storefront requirements, what is the dealing requirements that exist, and so on. So as we saw before, Storefront invokes a aggregator capability to add the given piece to aggregate. Here on the left is the actual UCAN for that. So Storefront Web3.storage asking aggregator, please put this piece into an aggregate. And note that that grouping there, that grouping is what allows us to, at the aggregator level, have different aggregates being built at the same time with different characteristics. Maybe we want different replication. Maybe we want different SLAs and want aggregates that need to be there super quickly into a deal. Others maybe can take more time. So we can have multiple aggregates being built at the same time. So aggregator received this request from Storefront to have piece into an aggregate. This will take quite a while as well. This will be an asynchronous task. So once again, there is a receipt where aggregator says to Storefront, okay, I got this. I will get back to you soon. And here you have the fx join CID for the piece accept receipt that will issue soon. I want to zoom in a bit also into our aggregation workflow because I think it's quite interesting and different from everything else that I've seen before. So we have basically a queue-based implementation that goes from piece to bigger buffers and buffers of big pieces together until we get to the point that this buffer is so big that it can't go into an aggregate. So every time that the aggregator receives new requests from Storefronts to have pieces, these pieces will be queued. These yellow and green colors is just different groups for illustration purposes. So when this piece queue has a large number of pieces already queued, that's when we can create a buffer. And this buffer is basically we grab a batch of the things in this queue and we put all of them together into a buffer, because we optimistically think, okay, like let's consider, for example, 1,000 pieces. It's very likely for the size of content that we ingest that 1,000 pieces will not even be enough for an aggregate. So as soon as we have 10,000 pieces, we create a buffer from those and we store this buffer into a store. And once that happens, we can put this buffer into a second queue, which is the buffer queue. The buffer queue, what it does is essentially each time there are 2 buffers available in the queue, we immediately consume them and we just concatenate them together. So we create one buffer from these 2 buffers, and at this point we think, okay, maybe now this will already be enough for an aggregate, but maybe not. So let's validate if this candidate can be an aggregate. This will depend, as I told you, on what are the dealer requirements, what is the intended size we want for an aggregate. And also worth mentioning that in order for us to have a optimal storage into the aggregate, we sort pieces by starting by the bigger one until the smaller one. So zooming in a bit more into the buffer queue part, as you can see on the top side, we did first one concatenation. It was sadly not enough. Then we do a second one. And then on a third one, you can see this blue plus the yellow box that comes from the top will result in something that is already enough. So we already have in this new buffer what we need for an aggregate. When this happens, what we essentially do is, okay, we have enough. This buffer can now proceed to the aggregate queue to be offered for a deal. But this buffer actually could have more stuff that the aggregate adds. So the remaining also, as you saw on the right side, needs to be put back into the queue so that it goes into the next one. So the highlight of this aggregation system compared to the one that we currently have in the current API of Web3.storage is that we only keep pointers for the pieces. So we can track their sizes and we can create the aggregate tree without actually needing to concatenate all the bytes, move them around, and create this huge aggregate file that we need to store with all the replicated data so that then we can move that data into a DSP. Everything here is just, we already have the car files and everything is just pointers for them. It was also worth mentioning that we are building this on top of FIP58, the verifiable data aggregation, so that we, once again, everything is about proofs. So we want, of course, that also the proof of data segment inclusion for each piece of data is available. It's also worth mentioning about the grouping. So we also wanted to have the grouping in the protocol where we can have multiple aggregates that are built at the same time for multiple purposes, like the deal requirements or even considering the storefront interaction with the aggregator. We might have multiple storefronts, and multiple storefronts will mean different wallets. And then if at the very end, when there is a deal, we need to know like who actually made this deal, and if we would mix all the pieces of multiple storefronts in the same aggregate, then who would pay for the deal. So back into the aggregator workflow, this aggregation async workflow app node, as we saw, now we have an aggregate there. So the aggregate was for this piece, of course. So then the aggregator can just issue a new receipt saying, okay, storefront, everything is good. We already created an aggregate for the piece that you asked us for. Here you have the proof for it and what is the CID of this aggregate, the inclusion proof. And if you want to keep following the chain until this gets into a deal, there is the effect FX join to aggregate offer. So who is next is the dealer. So we now have the aggregate, and the aggregate needs to go into a Filecoin deal. So the dealer is basically a principal that arranges Filecoin deals with SPs. So as we saw, aggregator invoked the aggregate offer capability on behalf of storefronts, saying, okay, so we already have an aggregate with reasonable size by the storefront, and the storefront now wants you dealer to put this into a deal. So there, what is interesting to also see is that the NB field, so what we pass as aggregate offer parameters, is the CID of the aggregate, and considering that this aggregate can have under 1,000 more pieces, we actually will not put all the pieces there. We just put we encode all those pieces in this list of all these pieces with DAXIBOR, and we essentially just pass the CID that then the dealer can look for in order to get all these pieces. The dealer received this request. Once again, like everything else, there is an acknowledgement receipt saying, okay, I got this will take some time. As you know, then getting from an aggregate into a deal still might take a bit. So this is actually the same pattern as before. There is the join invocation for aggregate offer that at some point, aggregate accept, sorry, that at some point will be also executed. So dealer received an aggregate, and now it will asynchronously get that into SP. For this, we are currently working with the Spade team, and so one of our implementations of the dealer will be backed by Spade. And for this, what we essentially are doing is a dealer receives these offers are written into a bucket, and on the schedule that is possible for the broker, so for Spade, the Spade will collect these offers from the bucket and try to match them with SPs interested in storing this. However, it's worth mentioning that this is all open, everyone can interop with us, so even an SP could just implement the dealer, and it could also shortcut just reading offers and immediately put them without needing to have the broker in the middle. And that actually would mean that us pooling for the deal being done could actually maybe not be needed, but yeah. So once SP gets a deal contract with the storefront, each individual piece of the aggregate can now be fetched from the SP, which is different from today, where today what we do is we just give all the bytes from all the aggregate, while now we would be given just a URL, and with this URL they can download each individual piece and then put them all together with the padding and then see and validate if each PCID matches to what they compute on them on their side. And considering that, I forgot to mention before, sorry, but it's required that we keep the pieces order in the same way that we generated the CID of the aggregate. So then on the SP side, everything will match correctly, and then SP will be able to match all the PCIDs, including the variant for the aggregate. So if everything went well, the deal is now going to be included on chain. And that's where the last service comes in, the deal tracker. So the deal tracker, which I found curious that Xian had the same name in Singularity, is a principle that watches activity on Filecoin chain. So this way, when a deal becomes active or when a deal becomes inactive, the deal tracker will know. And why this is important? Because once again, we are now back into the dealer flow. So the dealer will need to know when the deal is made, that then he can issue the receipt saying, okay, this was done, aggregate accept, and so on. So once in a while, the dealer will need to ask the deal tracker, please give me information about the deal for this CID. And the deal tracker will say at some point, okay, yeah, now there is actually something here. So the deal tracker issues a receipt saying, okay, these are the deals that are available for this aggregate CID on the left. So you can see a deal. There is currently one deal with ID 111, and what is the SP that is storing that deal. So by now, I think user might already be wondering if the uploaded car made its way to the deal. Maybe not. Dude, where is my car? And now you can verify it. So first the dealer. As we saw, the aggregate offer invocation happened. Then the dealer continues polling the deal tracker until having news, okay, now there is a deal. So now the dealer knows, okay, the deal already happened and succeeded. So we can issue the accept receipt with the proof, the deal aggregation proof saying, okay, this deal is done and you have all the information both for inclusion proof and for the deal identifier. And later on, the user, right? So when Storefront discovers a deal is on Filecoin chain, the final signed receipt is issued, in this case by Storefront. So do you remember this very beginning that Filecoin accept had also the FX join for it? Now it's the time that this receipt is also issued, which would be the shortcut without the user needing to go all the way until the very end. So to recap, here is the full view of the pipeline. It seems quite complex, but end user actually only needs to interact with the left section. So invoke the Filecoin offer, and then it could actually just track the very last thing. So this piece accept receipt, and it would just be once in a while saying, okay, is this piece accept receipt already available? And of course, if a user is interested in doing so, they can follow all the other receipt chain and we'll get to the same result in the end. So all of this is spec'd out. You can have a look in the specs repo, and if you want to implement something interop with us, you are welcome to. And to finalize what is next, so we are in the final process of getting this into production. So for this, we are still working on finalizing the dealer implementation in the interaction with Spade. And once that is done, we will be able to put W3 Filecoin pipeline running into production, also unblocking W3 app being shipped. And also one thing that we sadly don't have yet and might be not so difficult to implement is a PubSub implementation to subscribe to receipts. So now users to know when these receipts happen, they basically would need to poll once in a while, do HTTP request and see, okay, this exists already or not. So actually they being notified for that would be way nicer. Then we also need to talk about failures. And in the spec you can read about that. I don't want to cover that into the presentation because it would take quite more time. But essentially when deal would fail, the deal could fail because maybe one piece was bad in all the aggregates. So at that point, we can point the receipt of the aggregate accept failure to basically offers of new pieces to be queued again. And that's why everything then would be tracked and user could even see that the previous aggregate failed and now the piece will be aggregated again and so on. And of course, monitoring and metrics will also be important. Thank you. I know you might be angry already, but you can still do some questions.
Any questions?